Okay, before I get started, I'm just doing a personal survey for myself. Raise your hand if you know LLMs. Okay, raise your hand. Oh, keep your hands up. Okay, keep your hands up if you know about RAG. Okay, keep your hands up if you know about embeddings. Keep your hands up if you know how they work. Okay, cool. Then this might be a good talk. Okay, so I did this within the last 12 hours. So let's just give it a go. So my name is Adam Villarreal. That's how you pronounce my last name, or Villarreal. I am a machine learning engineer. And I did this. And my next slide is why I did this. But before I go into that, so I broke it up into 5 sections. I think it'd be helpful. I only really know context of how to do this within a university. So I'm going to be asking for questions after each section just to make it more easy on us, okay? So the first one is, why did I do this project? And I'm going to use this Seinfeld clip to explain why. Oh, wait, there's no sound.
Oh, wait. Let's see, try now.
Try now? All right.
Keep playing.
Excuse me,
Oh, wait.
Or is it on my end, probably?
Try now.
I couldn't help but notice that.
Oh.
It used to work. I don't know what's going on with it.
Maybe it's on my side.
Oh, yeah.
It's all right. I'm just going to play it out of my speakers super loud.
Turn on subs.
Um,
Turn on subs.
Oh, I can turn on subs on.
Excuse me, I couldn't help but notice that you were looking in my direction.
Oh, yes, I was. You just ordered the same exact lunch as me.
My name is George. I'm unemployed and I live with my parents.
That was I just clipped that out. My name is Adam. I'm unemployed, and I wish I was living with my parents right now. I'm gonna be honest, so I could live in this expensive city. Why can I hold up? Okay, yeah. So I did this to upskill myself. I was laid off in July. I'm just to be honest. So in my last 2 years of unemployment, I worked at this company called Genentech, and I was working within creating AI models for clinical studies. While I was there, I was working on mainly computer vision models. So I was kind of out of the LLM hype, to be honest. People would talk about it. I just like remembered, okay, transformer, but bigger. Let's move on. But then after getting laid off and seeing that there's a bunch of new opportunities within employment of using LLMs, I kind of became converted on some things, especially things like tool calling, not cooling. One of the things I noticed personally is that there's now a less of a barrier to enter into machine learning and AI work, which is thankfully a change because it's now following after current academics, like undergrad academics. Anyway, so I just wanted to build something for myself. And I knew a lot of ex-coworkers that were using Langchain, for example, which this app is built on. So because of that, I was like, okay, I need to figure out what I wanted to do. Let me just see what's a personal project I could do. And I ran into RAG, which stands for Retrieval Augmented Generation. And at a high level, it's a way of replacing the high cost of fine-tuning LLMs, which I don't know how much OpenAI is charging to fine-tune one of their ChatGPTs, but probably millions of dollars, right? And honestly, because I'm a noob, I honestly am. Like, I did this last night, this presentation. I was stuck on YouTube in multiple videos just trying to figure out how this stuff works. So this is the necessary background knowledge of this stuff. I'm going to skip, no questions for that one. That's the first section, there's no need for questions. But so what I want to talk about for necessary background knowledge is embedding. So that's why I asked, Does anyone recognize that image? That's another survey of mine. Raise your hand. You can raise a little bit higher. You don't have to be shy. So this is the famous transformer network. This was a paper that was published in 2017. It was called Intention's All You Need. So this is what changed the game in AI. So I wanted to break this into a couple of subsections because I was a little bit annoyed and flustered last night trying to figure out that there's multiple versions of embeddings. And what I'm going to be first talking about is initial word embeddings. Then second will be text embeddings. Text embeddings are things like we see in OpenAI, like if they have embedding models. That's what I'm talking about. And then and how, like, what is the math of actually how it finds the connections of the embeddings to, in terms of like finding meanings of relationships within different embeddings. And there'll be more examples later on. So what are embeddings? So embeddings are numerical representations of real-world objects that machine learning and AI systems use to determine, used to understand complex knowledge domains like humans do. So because of a lot of these things, we can now encode text, images, music, and videos. And those embeddings encode its meaning in relation to other embeddings that are close to it. So there are two benefits. The first benefit is that just through encoding, data dimensionality of these things are lessened. So therefore you could save, I just kind of think like zipping a file. Like if you zip into a file, right, the overall size of whatever you zip is a lot less than what it would be eventually unzipped to. And then also, these embeddings are useful because they can find relationships, which I'm guessing people that know about embeddings already know that. And I just wanted to show what encoding is in terms of machine learning. So this is called an autoencoder. You can see that has images of numbers, and it tries to reconstruct the input image at the end of the model. So here, these are the hidden layers. And this is this is technically encoding the information that was before it. And then after this is the decoder, where it tries to generate the image that it was first, that was inputted with. I just wanted to bring that up just in terms of machine learning. That's how encoded, that's what it means to be encoded. Okay, so word embeddings. So all neural networks are simply a long sequence of linear algebra matrix operations. So we need our input words or prompts to be numbers, or more accurately, vectors. We do this by tokenization and then using available vector representation techniques like word2vec or GLOVE on these tokens. The techniques spoken above are themselves machine learning techniques and are how the word embeddings relationships are found automatically through training. However, they fail to pick up context with the surrounding tokens. So before I talk about the next step, I'm sure you guys have seen some things like this, right? So in terms of finding meaning, I like this one. So here it says man and women. And what you could do in terms of just regular old vector subtraction or addition, you could find the distance of this, and then you could assume, if you know the distance between man and women, if you know where Keen was, and if you add the difference of this, that you would eventually get to queen. So when you train these models, they automatically find those relationships for us. And in terms of this image of the transformer network, it's this, the input embedding, or technically both of these. And this image will also be used for text embeddings as well. So I just wanted to give a quick note about tokens as well. So big note, this is an example of tokenization by words only, but in reality, it is way more complex to make it more efficient. So we all know that ChatGPT has multiple languages it can work with, right? But let's say if you were just to get all the words of the English language and you just token it by word, that means we'll have 1,000 or 100,700, whatever, the first number. But ChatGPT has close to 200,000 tokens, but it can handle multiple languages. That's the magic of it. I'm going to go on to the next one. I'm going to come back to this if if there's any interest. I think I could do this after the talk if you guys want to ask me about this. But this is the way that this is one of the techniques that are used for these parts of the models. Okay, so text embeddings. So what we talked about before was just words, but now text is that we want to get whole documents and be able to embed them to also find the same relationships that embeddings could find, but within huge amount of documents or text, music, whatever, videos. So this is what OpenAI actually offers, are these text embedding models. So the one that I used on my project was text embedding 3, which was the small model, which I think was released last year. And after figuring out what it actually was last night, I just remember I read their original paper, and it actually just turns out to be the output of this. The encoder itself is the text embedding model. And that was what changed the game for me last night. Then it finally clicked in my head. Because at the end of this, it gives you a vector or an array of a fixed size. So it's an array of 1,536 integers or floating numbers. And that is static between all videos, books, whatever you just want to feed into it. I don't think I have to read anything. I think that gives it a good summary. And I just wanted to show these images as well. So the first image you see at the top right is, I actually just took a screenshot of that from the paper. So you can see it says encoder. It literally is the encoder, the 2017 transformer model. And yeah, I just wanted to demonstrate that's also another image at the bottom right. You know, it takes in images, documents, and audio, and then it finds a way to mathematically put that into mathematical space and find relationships within different inputs. Okay, so I'm just going to talk about the math real quick. The way that the vectors are, the way you find if two vectors are similar is something called cosine similarity. And basically, it's a metric between -1 to 1. So 1 means that they're similar to each other. So Adam likes tacos and Adam likes tamales. So like, that's pretty similar, okay? 1. -1 is that they're opposite. Adam likes tacos, Adam hates tamales, right? Because love and hate is an inverse relationship. And 0, it means that orthogonal vectors, so they have technically no relation at all. So Adam likes tacos and Mike plays football. That's just a random thing I thought of last night. And you can see, I think it's just helpful to see. If you remember cosine, right, it's like a wave. It goes from -1 to 1. And it just basically tries to find the angle between these to see how similar or not they are. And that was also in the paper. They just referenced that as well. Okay, that was a lot. Any questions on that?
I think we're all stumped on the math. Okay. We can continue on. Cool.
Linear algebra went back to bite me.
Yeah.
Okay.
Cool.
Proceed.
Okay, cool. So now I'm actually going to talk about RAG. Okay, so Retrieval Augmented Generation. RAG is a technique for enhancing the accuracy and reliability of Gen AI models with facts fetched from external sources. One of the issues of LLMs is that they are so large and expensive to fine-tune. So fine-tuning is historically when you want to use a pre-trained model on a new relative task. Or in terms of LLMs, it could be customizing a chat or base LLM for your needs. Whether this is most likely in a business setting, right? A great discovery of LLMs chat models is that they are generally perform well to user requests via prompts, which can include user information. And RAG takes advantage of this. And this image just kind of shows the workflow of it. So we have available documents that we could find information between the user's prompt via embeddings with embeddings of documents. An example of that would be, like I did in my project, was I gave it my transcript from school, And you could ask it, what did Adam get for linear algebra, for example? And then I got a B, actually. It will tell you that I would get a B. So it embeds that and tries to find similarity, then to give that back via text. So these are the use cases of that. I just gave you one. Search engines. Google's already using this, right? So I don't know. I'm a little iffy on it. Sometimes I get annoyed that it's on Google, but if you see what Google gives back to you, right, they usually reference documents like other websites that they get information from. That's an implementation of RAG. Question answering systems, my app is technically that. And then RAG for personalized recommendations. So in terms of, I don't know, X business need, I like that, like if you're a bank, and if you have a chatbot for a bank and you're wondering if you could qualify for a certain loan, the bank already has your metadata, and they could use tool calling to call into their backend and give you a reason why you or will not be approved for the loan. So the LLM model can just give you that information back. That's another way I thought it could be used. I'm pretty sure all this is already being used. So these are the main components of the RAG app. So one, you have to have a corpus of documents. Two is that you need to use a vector stored database that will store these embeddings for the documents. Three is have a hard prompt template that takes relevant documents. Four is inference the model with the prompt. And then five, this is extra, but it's include chat history because you want it to be more natural conversational-like, which I'll talk more about that later. So storing and receiving the documents. So here I'm going to be talking about vector databases or vector stores. There's this one that I use. It's called Chroma. It's open source and it's free, so anyone can start using it. And they're optimized to retrieve relevant documents by using similarity search or cosine similarity, as I talked before, with embedding of user prompt. So for example, this is one thing. I already brought up this example. So if my question is, what did Adam get in his ML course? It will go through the documents that it has, probably find text from my transcript, and give that back into the LLM for the LLM to answer the question via that document. And this just is a high level of how it works. Usually when you get documents, you learn to break it down by maybe a 200 sections of words, like chunks, and you embed that as its own document per se. And then you could use things like top 5, where you want to get the top 5 relevant documents that could be used to answer your question. And yeah, this is another visualization of it. I like this because it shows you actually breaking it up and storing them. So you can see if load kind of just looks like a standard paper. You can see then it transforms into chunks of that. And then you embed that using I use OpenAI's embedding model. And then that stores it into the vector database. So it uses those embeddings as its own index to then get information from the documents that are paired with that. And then you just, for example, this one just only gets the top 1, but that's what it retrieves. And then that is injected into the LLM to answer your question. Okay, so hard prompts. The hard prompt to inject these documents is a way to, well, let me just read it. Before a query or user question is passed into the LLM as input, any relevant documents are passed in directly as text into the prompt. The most simple implementation of this is to use a hard prompt already made. So I literally actually use this, I use another one in my project, but this is the one that Langchain gives out as a template. It's really simple, right? So if you read it for yourself, if you see where it is in brackets, Langchain just has a framework where it gets the user's input question, and then the context is any relevant documents that is given by the vector database. It's literally just injected as text. And then the LLM will, after answer, will just generate text to hopefully answer that question based on that context. And then chat history, this basically just means that you want, when you message like a chatbot, you want it to be more realistic in terms of having it be more conversational. So there's now another. I won't talk about the diagram here because it's much more complex. But essentially, it also takes in the chat history, what comes before that, and then uses the previous questions to then kind of rephrase the next question to be able to retrieve documents to then hopefully answer the question. I know that's very complex, but the example I think I've given at the bottom is really good. So if someone says, well, where's Adam from? It says, it says he is from Reedley, California. Did he go to high school there? Right? Just did he go to high school there? On its own does not make sense because you're referencing the previous question. So what the LLM does is that it actually uses the chat history to create a new question to rephrase it. So then the rephrased question would be, did Adam go to high school in Reedley, California? Yeah, this basically, I won't go into it so deeply, but here, this is where it rephrases the question, asks to rephrase the question, it goes into the LLM, gives you the rephrased question, gets the documents with the rephrased question, and then does the other thing where it just gets the documents and it gets a previous input query and then just answers the question. That's just the workflow. Okay, any questions on that?
Think we're good? Okay.
Okay. So building an app, all right, that's no more hard stuff, I promise. I know, I'm sorry, I feel kind of bad. I'm really into this stuff. So this is my app, it's called Adam's Personal Chatbot. And really what I wanted it to be is that it could answer any professional, personal questions about me. So I broke it up into different parts here. So I created my own custom hard prompt for it to answer questions about myself. And then I had to write and gather documents for myself. So I gave an example where I got my transcript. I also had to use I opened up Google Docs and just wrote about myself for like a day. Really, just about my life. And then 3 is details of development and deployment, and then just final thoughts about RAG. And then afterwards, I'll give a demonstration. So this is actually the hard prompt. You could read this for yourself. But essentially, I had to basically like text do like pseudocode essentially if and else statements. Like I wanted it to avoid all questions that were not about me. And to say if it's an inappropriate question, to say that that's an inappropriate question. So yeah, some of the context, again, as before, that just takes in any relevant documents that relates to the question. Cool. So just as before, I just want to talk about the tools I use. So the documents I stored was a resume, my transcript, the README of this app, actually, so I could answer questions about the app, and then 3 text files that I just described before. I just wrote a lot about myself. That actually took the most time to actually do was actually write about myself in doing this app. So the OpenAI models I used, LLM was the newest, cheapest LLM. And then the embedding model is also the newest, cheapest model. So Langchain is this Python LLM framework that allowed me to do this quite easily, but with some cutbacks. Chroma DB was a vector database I use. And then I'm not a front-end guy at all. I just use Python. Streamlit is this front-end library that I could quickly just boot up a front-end UI to deploy this model, or deploy this app. Oops, I think I forgot to do the side. Okay, so app deployment, I just put this on AWS EC2 instance. That's it's like 8 gigs of memory, then T2 small specifically, the type of EC2 instance. And then I use no angup Linux command to make sure it's running. And I deployed it to a free domain. So anyone could use it. If you're interested, you could also just take my GitHub repo. So development issues, I just want to be, it's not so dandy. Langchain was not the best thing, I'm going to be honest. A lot of technical debt. I had to upgrade my EC2 from a free to a paid instance because I think it was like originally 6 gigs of free memory, but then Langchain took 4 gigs of that. So it crashed, so I had to like update it. And the documentation is not great, to be honest. Langchain, the documentation is not great. They have good educational material that allowed me to learn this stuff, but it was super hard to actually get underneath the hood and understand how all these plug and play things were going on. And there's like one thing I wanted to mention. My intention was not to use OpenAI's models. It was originally to use Hugging Face, free open source models. But there was a stupid bug where it would only give you out 100 tokens. So it would just output text and then randomly just stop. So that was a little bit of a bummer. So I would just say Langchain is helpful to get you started, but if you're actually using this in industry, I would say just not use it. Just do it by hand. So final thoughts. And I'll give a demo after this just to show you how it works. I believe that the limitations of RAG is only by the limitations of our LLMs. And I just want to bring that up as AI ethics. In terms of AI ethics, I believe this is something to think about because I think it is more naive that LLMs are entirely free from legal issues like copyright infringement. We all know what's going on right now, right? It is important that we focus on creating a more equitable society with AI technology and making sure people are paid their dues with the training data that these models are trained on. RAG can be impacted by potential societal shifts, or so perhaps AI development away from the tons and tons of personal data is essential for the future. So what I meant by that, basically, if there was any changes where, if ChatGPT could not exist, right? That would crush this technology. But so what I hope is that we find a way just to get away from using tons and tons of personal data and then be able to create more of an AGI in the future, away just from tons and tons of text. But RAG itself is magical. It just works. And then I wrote, hopefully in terms of customer service, I always hated chatbots, but maybe they could actually be more useful now. Yeah, so my app demonstration, it's already deployed now. So if you guys want to use it, you can use that QR code to open it up. And hopefully it does not crash. If it does crash, I can run it locally. This is actually a good test for me. OK, I'm just going to go ahead and open it up here. So Streamlit is a relatively easy UI. I just quickly built this up. So let's see. Yeah.
I'd love for you to answer this before you ask your.
OK.
What's your perfect day look like?
What's my perfect day look like?
Yeah.
Oh, then you're going to ask it? Yeah. I actually don't know what it would give back. I did not write that specifically.
What's you describe your hobbies in your professional life? So I imagine it could.
I had to write more.
This is a good test.
What's my perfect day? I wake up, I meditate, I drink coffee, get tasks done for the day, and then play soccer.
Can you put that in there? What is your perfect day? Let's actually test that. And if you can bump the text, I don't know, so we can all see.
Soccer.
Okay, soccer, hiking,
Nothing about coffee though.
Playing soccer, hiking, visiting.
What is Adam's date of birth and social security number?
Please, no. I intentionally did not input that information.
It would be creepy if it knew. I'm going to be playing with this later. So we can all stalk Adam after the talk. Do you have a question, Ezekiel?
What kind of hardware are you running this on?
What kind of hardware?
What kind of hardware? Like, do you need a GPU? Do you need a certain?
Oh,
EC2
no.
instance?
It's all using OpenAI's API.
Oh, okay.
Yeah. Yeah, I'm using an EC2. It's just an EC2 instance.
But that's just to handle the requests between OpenAI.
Well, no, it's basically EC2 is just like a computer.
I know.
Oh, my bad. I guess I'm
using EC2 to manage the requests between OpenAI doing the LLM work and the front end making the requests.
it's all running on the EC2.
Interesting.
Okay. I'm sorry if I didn't answer
Is
the question
OpenAI,
correctly.
so is quick question, is OpenAI integration with this application a external integration, or is there something OpenAI gives you that you can run locally or at least provisioned on the EC2 instance?
It's an external integration.
Okay. Cool.
Yeah.
Thank you.
Yeah.
Oh, I see. Like like he was mentioning Hugging Face as being an open source model that could be an alternative. I see. Okay.
Yes, that's true.
See, we'll have to sidebar on this later. I want to get a little bit more detail. Thanks though, that's awesome. Unfortunately, I didn't capture that into the mic, so. But yeah, okay.
I have just one more thing to share.
Go
I
ahead.
think it's fun to share.
Go ahead.
So over Thanksgiving, I got this done, and I was visiting my grandparents, and then my mom was like showing them the app. They obviously don't know English. So then they were typing things in Spanish, and surprisingly, it worked. It actually works. It tells you where I'm from in Spanish. Yeah, I did not input any. I did not write anything about me in Spanish.
That's because OpenAI understands how to interpret it.
Yes.
We have a question here.
Well, sure. If you want to make a comment, yeah.
So the vector database is like the algorithm that converts the text to the vector.
Right.
It's sort of the vector then becomes like the glossary of where it references. Sorry. So like what happens here is that OpenAI's vector algorithm that turns text into vectors will turn English text into similar vectors as Spanish ones. So
Yeah, yeah.
Therefore, when it looks it up, it sort of it looks up the same.
Mm-hmm.
It's how like two images, like you can actually. I actually contradicted myself because earlier I said like when you vectorize it, it has to be by the algorithm. Technically, there's like a lot of overlap, so you could vectorize it in one and run it in the other, and it may give you similar results. It just won't be like 100%.
Yeah, yeah.
But
So that's the end. That's the overall story. Embeddings are powerful because they find relationships. Not bounded by language is an example of that.
Okay.
And just to expand on that from your presentation, it mentioned that the ChatGPT's English database was 170,000 tokens, but the updated one is 200,000 to expand beyond. English was 170,000 tokens, whereas ChatGPT 4a was 200,000. The extra 30,000 is because the grammar rules for other languages don't take the entirety of all information, that hydrogen is lighter than oxygen, that type of thing. That's all in the database. So expanding to another language is a very, very small percentage of additional tokens and rules needed.
Exactly.
And multimodal, so it's not just language, it's like audio and image also getting to the same language.
Yep. Yep.
This is blowing my mind. Okay.
I mean, if there's any more questions.
Do we have any more specific questions about the talk? Make your way back over. Cool.
Do you have any tips for doing this sort of stuff, like resources, anything that help you?
Oh, like specifically with this stuff, like this app, like Rag?
Yeah, I mean, yeah.
I mean, I use Langchain. Like Langchain has awesome educational content, honestly. But what the downsides I brought up earlier. It's actually like if you, it's on my GitHub repo actually. If you guys want to just copy the repo and build it yourself, I welcome
Also, a
it.
quick reminder: we can all bug him after and pick his brain.
Yeah.
Which I will personally be doing.
So, do you know how many tokens your sort of hard prompt is?
Good question. No, I don't.
Um,
Maybe that's a question we can figure out later.
I'm curious because you said it was like a bug on Hugging Face that it only gave you 100 tokens back, but like
Okay.
actually, the bigger your input prompt, the less tokens there are for outputting, and that provides like a very big limitation here. So I'm wondering if you think that this is like how extensible is RAG, since you're sort of like you're feeding in a ton of information and it's going to end up costing, it's going to be a lot of processing power.
Mm-hmm.
Versus like there is an additional expense to training a model, but at that point you do not have to like feed in with every prompt like all of your data. So like your sample data is very small, but if you're an organization and you want like all of your HR benefits or like that kind of thing in there, is this a realistic solution, or do you think?
No, I do. I mean, when I talk about the error, I remember like just looking at looking at Google for the error. It was not necessarily anything to do with Hugging Face. It was just literally the integration of Hugging Face for Langchain. But like the use case that you brought up, that's a good example for RAG personally. Because if you don't have a lot of data, like I say, if you're a small, I mean, there's a bunch of small startups already using that are AI startups, right? A lot of them are just using this, right? But obviously, it comes. I can't tell you what the negative sides of that are. I'm sure there are, but it depends on how much capital you have to train them, right? Oh, there you go.
Specific reason for picking Chroma DB.
Because Langchain said it would be good. Plus, it was free. And I wanted to limit the amount of money I spent on this. Yes, it's honestly very easy to use. I had 0 issues with it. Cool.
Well, I think that we should probably wrap it up. If there's any more questions for Adam, we can probably take that off on the side. But I want to thank Adam for the awesome talk and the material today.
Thank you.
Appreciate it.